Hello students, welcome back to my channel. In the previous class we have discussed solar radiation and its effect on crop, and today we will discuss about atmospheric temperature. Today we will discuss about atmospheric temperature. So what is atmospheric temperature? The temperature of our atmosphere or of our surrounding or of our gaseous mass that is covering the earth surface, that is atmosphere, and the temperature of that atmosphere is known as atmospheric temperature. So how does atmosphere gets its energy or temperature? Temperature is the form, that is the representation of energy content in the atmosphere. And how does our atmosphere gets its energy? From solar radiation, right? From solar radiation our atmosphere gets its energy. And temperature is the mainly, what is temperature? Atmosphere, all of you know what is atmosphere. That is the gaseous mass that is surrounded on our earth surface, okay, or surrounding our earth, that is atmosphere, right? The gaseous mass. So there are different layers of atmosphere like troposphere, stratosphere, mesosphere and thermosphere. Then what is temperature? Temperature is the hotness or coldness of any object. Temperature is the hotness or coldness of any object or substance, that is called temperature. And it is a representation of heat energy. It is the representation of heat energy. Temperature is the representation of heat energy, okay. So how temperature we can measure temperature? How we can measure temperature? There are different types of thermometer we use generally. We use different types of thermometer in our agrometeorological observatory to measure atmospheric temperature. What are those type of thermometers? There are maximum thermometer, then minimum thermometer, then wet bulb thermometer, then dry bulb thermometer. These thermometers are generally used for measurement of atmospheric temperature, and these are being placed in the Stephenson screen. Okay, where these thermometers are being placed in agrometeorological observatory, inside a box, that is a white box, and that is called Stephenson screen, right? This is a white box which is known as Stephenson screen, where this is the upper lid. Inside this Stephenson screen, these thermometers are being placed. So maximum thermometer and minimum thermometer, they are placed horizontally, okay. Inside this box, maximum thermometer and minimum thermometer, they are placed horizontally, and dry bulb thermometer and wet bulb thermometer, they are placed vertically, okay. So what are the role of these thermometers? Maximum thermometer actually measures maximum temperature in a day, okay, in 24 hours. What is the maximum temperature? That is measured by maximum thermometer, and this is a mercury in glass type thermometer. That means in a glass rod, inside the glass rod we have mercury, okay. So maximum thermometer is a mercury in glass type thermometer, and it is used to measure the maximum temperature in a day or 24 hour, okay. So when maximum temperature arises, when we can observe maximum temperature when? At around 2 p.m. At around 2 p.m. we find maximum temperature in a day. Why? You will answer at 12 noon. But why not 12 noon? Why 2 p.m.? Because Earth also radiates some energy in the form of terrestrial radiation, and those are long wave radiation, and they are being also trapped by our atmosphere, that is water vapor, different the dust particles, water vapor, dust particles, if cloud present, then by cloud, then different gaseous molecules. So they trap this terrestrial radiation that is reflected back from Earth's surface, okay. So again, they are being, as they are long wave radiation and they are having lesser energy, they are being trapped by our atmosphere, by the dust particles, by different gaseous molecule. So during 2 p.m. during noon we have direct solar radiation, okay, and at that time earth absorbs the radiation. But after some time, means around 1 p.m. or 2 p.m., it again, any object, if it is absorbing some energy, it will radiate some energy to stabilize itself, right? So terrestrial radiations are backscattered radiation from Earth's surface, and during 2 p.m. it will backscatter and it will warm up again the atmosphere. So during 2 p.m. The atmospheric temperature is maximum. So maximum thermometer measures this maximum temperature. Then minimum thermometer, it measures minimum temperature in a day. Minimum temperature in a day. So when we can find minimum temperature in a day? During early morning. We can observe minimum temperature of a day. And minimum temperature, the minimum thermometer is a alcohol in glass type thermometer. Alcohol in glass type thermometer, okay. Maximum thermometer, wet bulb thermometer and dry bulb thermometer, they are mercury in glass, okay. Mercury in glass type thermometer. Mercury means Hg, mercury. And the minimum thermometer is alcohol in glass type thermometer. This is important MCQ, okay. Then wet bulb thermometer measures the temperature of atmosphere at saturation point, okay. When there is saturation level reached, that means when there are enough water vapors in the air, at that point what is the temperature of the atmosphere, that is measured by wet bulb thermometer, okay. And dry bulb thermometer, that measures the instant air temperature, okay. Dry air temperature or instant air temperature. So again, the role of wet bulb and dry bulb thermometer, readings are being presented in relative humidity table. For preparing relative humidity table, wet bulb and dry bulb thermometer readings are used for preparing relative humidity table, and from where we can get relative humidity of the atmosphere. Wet bulb and dry bulb thermometer are also being used to measure relative humidity of the atmosphere, right? So there are different thermometers are being used in agrometeorological observatories for measuring the atmospheric temperature, like maximum thermometer, minimum thermometer, wet bulb thermometer and dry bulb thermometer. So what are the units of atmospheric temperature? What are the units of atmospheric temperature? What are the units of atmospheric temperature? They are Celsius, degree Celsius, degree Kelvin, degree Reaumur, degree Fahrenheit, okay. So what is the relationship between these units? That is C by 5 is equal to K minus 273 by 5 is equal to R by 4 is equal to F minus 32 by 9. So if you want to convert from one unit to another unit of temperature, then you must remember this formula. That is C by 5 is equal to F minus 32 by 9 is equal to K minus 273 by 5 is equal to R by 4, right? So this is about how to measure atmospheric temperature and what are the units, okay? So there is temperature, as we discussed, temperature is the representation of energy, okay? Temperature is the representation of heat energy. So how heat energy is being transferred? How heat energy is being transferred from one place to another? There are different transfer methods, right? One is conduction, another is convection. Heat energy transfer methods are, one is conduction, one is convection, and another is radiation. What is conduction? That is the heat energy transfer through molecular activity or molecular vibration. Through molecular activity, molecular vibration mainly, okay. to molecular vibration, and it is mainly you can find in solids. The heat transfer in solid, that is conduction. Then what is convection? That is the molecule itself carry the heat. Molecule itself carry the heat, right? Molecule itself carry the heat energy or temperature. Okay, so this is mainly found in the gases and liquids. Okay, convection. Then radiation, it do not require any medium, does not require any medium for its transfer, and this is mainly through electromagnetic radiation. Okay, we have already discussed in solar radiation portion, right? Radiation. So if we boil suppose this is the stove and we are boiling some water. Okay, we are boiling some water over the stove, right? Gas stove. So what happens initially this pot will warm up. So if you touch this pot, okay, the boiling is here, the flame is here below the pot. How the upper portion it warms up? That is due to conduction. And how this liquid, when liquid warm up, that will move to upward. That warm liquid will move to upward, then cold liquid that will move downward. That is due to convection. And you also, if you keep your hand outside the gas burner, then that will also, you can feel the heat. That is mainly radiation. So this is how the heat transfer happens, right? One is due to molecular vibration, that is conduction, mainly occurs in solid. One is due to the movement of the molecule, that is present in gas and liquid, that is called convection. And one is that doesn't require any medium for its transfer, and that is in electromagnetic waveform, and that is called radiation, right? So the speed of the energy transfer, that is highest in radiation, than convection, than conduction. Okay, the heat energy transfer, the speed of heat energy transfer, that is more in radiation, that is again more from convection, and convection is more than the conduction. Okay, so there are two types of heat energy. One is latent heat, another is sensible heat. What is latent heat and what is sensible heat? If there is phase change, suppose we are boiling water, that converts from liquid to gas. Okay, we are boiling water and that converts from liquid and gas. So the temperature you can find in liquid at that boiling point, the temperature here of liquid is around 100 degrees Celsius, and gas is also the water vapor, that is also around 100 degrees Celsius. At 100 degrees Celsius, the heat energy here remains same. In latent heat position, the heat energy remains same, but there is a phasic change. Okay, phasic change will happen. Okay, this is called latent heat. Then what is sensible heat? We can sense that temperature and we can see the gradual increase or decrease of temperature. We can measure that temperature. Here. Okay, this is a value. That is called sensible heat. We can sense this temperature. In latent heat, we cannot sense, means the heat energy remains same, and the phasic changes happen, like liquid to gas, or maybe if we are freezing the liquid or water, then from liquid to solid, that is the phasic change. There we can sense, we cannot sense the temperature, or temperature doesn't differ. That is called latent heat. And in sensible heat, we can sense the temperature, we can sense the energy. Then how at different places of our surface, how at different location or different places of our surface, temperature varies. Okay, temperature distribution, how temperature distribution occurs in different Earth surface, different location, right? How temperature differs from one place to another. So there is mainly one is horizontal distribution of temperature, horizontal distribution of temperature, another is vertical distribution of temperature, okay, of temperature. One is horizontal distribution of temperature, another is vertical distribution of temperature. What is horizontal distribution of temperature? That means at different location to location in our Earth surface, or horizontal to the Earth surface in different location, how the temperature varies, okay, from location to location, how temperature differs, that is horizontal distribution of temperature. So how this horizontal distribution of temperature happens? It mainly depends on solar radiation insolation. That means how much solar radiation one place is getting from another location, and that depends on latitude of that location. How latitude affects the temperature or solar radiation insolation? If we move towards north or south latitude from equator, if we move, what is latitude? This is the equatorial line, 0 degree. If we move northward, that is called north latitude, and if we move southward, that is called south latitude. And how temperature or solar radiation differs? Solar radiation is directly incidented on equatorial region, but the radiation incidence is in slanting position, or the energy balance is different in higher altitude. That is the same amount of energy falling in wider area. So the radiation is not that much intense in the higher latitude, right? So in higher latitude, what happens? The temperature is decreases. There is decrease in temperature in higher latitude. Decrease in temperature in higher latitude. Okay. So latitude affects the horizontal temperature variation. Then what are the other things affecting horizontal temperature variation? That is, if there is a land mass and water bodies surrounded by any water body, then what happens? Here also temperature differs. Suppose one place is not surrounded by any water body. Suppose we for example, if we say suppose Chhattisgarh, if we say suppose New Delhi, okay, and another example is West Bengal or Odisha, where the temperature variation will be more. If we say Punjab or maybe Chhattisgarh or New Delhi, okay, and suppose this is one place, another place is Odisha, West Bengal, these are some place, okay. So where the temperature variation will be more, the temperature variation will be more in these states, okay, or union territory, Punjab, Chhattisgarh and New Delhi. And in Odisha or West Bengal, these are coastal areas, and there the temperature variation will be less. That means in summer you can find a normal temperature, and in winter you can find also a normal temperature or average temperature. But in Punjab, Chhattisgarh and New Delhi, you can find higher temperature in summer and lowest temperature in winter also. Okay, there is not normalization happens. So what happens if there is presence of water body? How the temperature differs due to difference in specific heat. Okay, difference in specific heat of water and air. Okay, what is specific heat? What is specific heat? That is the heat required or the calorie required to increase 1 degree Celsius of 1 gram substance. The calorie required to increase 1 gram substance to 1 degree Celsius, that is known as specific heat, and that varies from object to object. For water, the specific heat is 1 calorie per gram per degree centigrade. For soil, that is 0.2 calorie per gram per degree centigrade. For humus, the specific heat is 0.5 calorie per gram per degree centigrade. Suppose two water bodies we are taking. One is having, suppose this is A water body, A soil, and this is B soil. Okay, this is A soil. Okay, both are soil surface or land surface, soil B and soil A. Soil A has 8% moisture. Okay, 8% moisture. Soil B has 15% moisture. So where the specific heat of which soil will be higher? The specific heat of which soil will be higher? The specific heat will be higher in this B soil. That means to increase 1 degree Celsius, we require higher energy, higher calorie of energy for increasing 1 degree Celsius in this soil. So if we are providing same quantity of solar radiation to both these soil, if we are providing same quantity of solar radiation, that means energy, to soil A and soil B, which soil will warm up faster? The temperature of which soil will increase faster? That is the soil A. Soil A will warm faster due to less specific heat. That means with same amount of heat energy receiving, the A soil will warm up faster than B soil, because B soil will trap more energy. B soil will require more energy to increase that temperature to reach the level of the temperature of A soil. Okay, are we clear? If the specific heat of a substance is higher, that means the substance require more energy for its increase in temperature, right? If the specific heat is lower of a substance, then that substance require less energy to reach that temperature level, right? So due to this difference in specific heat, what happens? If any land surface that is present near to any water body, sea or ocean, then what happens? During daytime, due to lower specific heat, this land mass will warm up faster. Okay, land mass will warm up faster, right? But this water body will warm up slower, right? So what happens? If it warms up faster, then air mass will move upward. Okay, air mass will move upward due to lightness of the air. Okay, so what will happen from these oceans? Because ocean is still cooler than the land mass, so here the density of air is higher. Density of air will be higher. So from here, air will blow towards the land surface. Okay, at night time, what will happen? At night time, the land mass will emit the radiation or radiate or cool down also faster. Okay, any object that warms up faster, that also cools faster. Okay, during night time, land mass will cools faster, and the sea or ocean surface, that will cools slower. So what will happen? Again, the pressure will be higher in land mass. So during night time, the wind will blow from land mass to water surface. So this is how there is temperature normalization. Okay, so there is a term in horizontal temperature variation. There is a term that is called isotherm. What is isotherm? Okay, let me write here. What is isotherm? That is the places. If we draw a line between places, if we draw a line connecting places having equal temperature in a particular time. Okay, if we draw a line connecting the areas having equal temperature in a particular time, that is called isotherm. Okay, that is called isotherm, right? Then vertical temperature variation. What does it mean? Temperature variation. What does it mean? How temperature differs if we move upward. Okay, with respect to altitude. With respect to vertical temperature variation is with respect to altitude. Okay, how temperature vary if we go upward, if we increase the altitude. Then If we see this is our surface, then what are the layers? Suppose this is troposphere, this is stratosphere, this is mesosphere, and this is thermosphere. How temperature varies from sphere to sphere? In troposphere, this is troposphere, this is stratosphere, this is mesosphere, this is thermosphere. In troposphere, the temperature decreases with altitude. In stratosphere, it again increases. In mesosphere, it also decreases. In thermosphere, it increases, right? Right or wrong? In troposphere, it is decreases. So this decrease in temperature, decrease in temperature with respect to altitude in troposphere, that is called lapse rate. Okay, that is called lapse rate. Okay, this rate of decrease of temperature with increasing in altitude in our troposphere, that is called lapse rate. So there are different types of lapse rate. Actually, there are different types of lapse rate. One is normal or average lapse rate. One is normal or average lapse rate. Another is actual lapse rate. Another is adiabatic lapse rate. Okay, so there are three different types of lapse rate. One is normal lapse rate, one is actual lapse rate, one is adiabatic lapse rate. What is normal or average lapse rate? That is the rate of change of temperature or the rate of decrease of temperature if we move from this place to this place. What is altitude? Altitude is the distance from or height from mean sea level. Altitude is the height from mean sea level. Okay, if we go upward in our atmosphere, how the temperature variation happens from one height level to another level, that is altitude. So normal or average lapse rate is the average out of different actual lapse rate in different duration. If we measure the lapse rate and we average out what is the normal or average lapse rate, the value of normal or average lapse rate is around 1 degree Celsius per 165 meter, or 6.5 degrees Celsius per kilometer, or 3.5 degree Fahrenheit per 1000 feet. Okay, 1 degree Celsius per 165 meter, 6.5 degrees Celsius per kilometer, or 3.5 degree Fahrenheit per 1000 feet. This is the normal or average lapse rate. What is actual lapse rate? What is actual lapse rate? Actual lapse rate means at a particular time, what is the lapse rate? This is a single measurement. Okay, one time or single measurement, one time measurement. Actual lapse rate is at a particular time. Normal lapse rate is the average out of different actual lapse rate, right? Then what is adiabatic lapse rate? Adiabatic lapse rate means we know when temperature increases in the Earth's surface, the air mass it becomes lighter and it moves upward. So when this air mass, after heating up, it moves upward, suppose from place A to place B, how the change in temperature happens? This is called adiabatic lapse rate. Okay, are we clear? What is normal lapse rate, what is actual lapse rate, and what is adiabatic lapse rate? And this value of adiabatic lapse rate, that is constant. For dry adiabatic lapse rate, for dry air, this adiabatic lapse rate is constant, and that is 10 degrees Celsius per kilometer. So what is the adiabatic lapse rate, dry adiabatic lapse rate value? That is 10 degrees Celsius per kilometer. So this is how vertical temperature difference happen. Okay, so if we find our atmospheric layers, like this is Earth, then there is troposphere, there is stratosphere, then there is mesosphere, and there is thermosphere. Between this troposphere and stratosphere, there is a thin layer where there is no change in temperature if we go upward. Okay, at that particular thin layer, there is no increase or decrease in temperature. In between stratosphere and mesosphere, there is also that layer present where there is no change in temperature. Okay, the temperature doesn't increase or decrease at that particular place. And what is this layer called between troposphere and stratosphere? That is tropopause. Tropopause. And between stratosphere and mesosphere, that is stratopause. Okay. Then between mesosphere and thermosphere, that is mesopause. Okay. So at this pause layer, there is no temperature increase or decrease happens, you can find. So this layer are known as isothermic layer. Isothermic layer. This pause layer, that is tropopause, stratopause and mesopause, these layers are known as isothermic layer. Why? Because here there is no temperature variation on increasing the altitude, right? So are we clear? There is a clear-cut difference between isotherm line and versus isothermal layer. Okay, there is a clear-cut difference you can find. In isotherm, that is the horizontal temperature variation. If we connect the line between different places of having equal temperature in a particular moment. What is the isothermal layer? That is the pause layer in the atmosphere. This is isothermal layer. So are we clear? Are we clear? Then another thing is there, that is called temperature inversion. Temperature inversion. Okay, what is temperature inversion? What is temperature inversion? That is, if we go upward, or if we increase the altitude, or if we go upward, then the temperature increases in troposphere, increases. Generally what happens? Generally it decreases, that is we call it lapse rate. But in certain condition, this is with respect to certain condition, okay, certain temporal condition or temporary condition, okay, not temporal, that is temporary condition. In some specific temporary condition, if we go on increasing the altitude, the temperature increases that in troposphere. That is called temperature inversion. What is temperature inversion? If at a certain or some point or temporary condition or some specific situation, if we go upward, the temperature increases instead of decreasing. Okay, so that is called temperature inversion. There are three conditions when temperature inversion occurs. Three conditions. Okay, remember. One is, so there is terrestrial radiation. All of we know in solar radiation section, there is terrestrial radiation during night time mainly. Okay, so what happens if the atmosphere is clear? Okay, and there is no cloud in the atmosphere, then what happens? This terrestrial radiation, they directly move to the upper atmosphere without absorbing by our nearby atmosphere, that is near to ground. Okay, they are not being trapped. These radiation are not being trapped. If they would be trapped, then the atmosphere would become warmer, okay, in the lower atmosphere. As they move to the upper atmosphere, the earth will get cooler, or earth will cool down. Why? Because if someone is radiating some energy, then the energy level is decreasing and the temperature also decreases of that object. So earth temperature will go down. So if earth temperature will go down, the nearby atmosphere, that will also cool down. Okay, the nearby atmosphere, that will also cool down, and the upper atmosphere temperature is higher than the lower atmosphere temperature at that particular situation, right? So in this particular situation, there is temperature inversion happen. This is one condition. The second condition is if there are hills. Okay, suppose there are hills and we have valley in between. So this is at higher altitude, this point is at higher altitude, and there the density of the air will be higher, so it will move down. As the density of air will be higher, then that will move down to valley area. So in this place, the cooler air, it gathers cooler air, and here the temperature will be warmer. So this is also another temporary condition or any specific situation in which temperature inversion you can find. Then third condition is when there is one cool air mass is coming from one side, from another side there is, this is cool air mass, this is warm air mass, they are coming from different side, Then they collide. When they collide, the cool air mass, obviously it is having higher density, higher dense layer, okay, that will move down, and the warm air mass will move up. So here also there is temperature is lower in cool air mass in lower layer, and temperature is higher in upper layer. So this is also another condition of temperature inversion. Can you write, if it is being asked in your exam, what is temperature inversion and what are the condition in which temperature inversion you can find? So another thing is diurnal and seasonal variation of temperature. Okay, diurnal versus seasonal temperature variation. Okay, what is diurnal temperature variation? In 24 hours, how the temperature variation is there. What is the maximum temperature and what is the minimum temperature within 24 hours, that is day and night, that is diurnal temperature variation. And this diurnal temperature variation is higher for inland or the coastal area. Two areas are there. One is inland, where there is no water bodies present, means no large water bodies present, that can significantly affect this temperature difference. Then another is coastal area, where there is the sea or ocean you can find. So where the diurnal temperature variation will be more. Diurnal temperature variation will be more in inland. Why? Due to difference in specific heat between water bodies and the land surface, and due to normalization of temperature in daytime and nighttime due to movement of wind, right? Movement of wind. That is, so in coastal area there is normalization of temperature you can find. So diurnal temperature variation will be less in coastal area. Then seasonal temperature variation, that means how from season to season temperature varies. Okay, this is also this seasonal temperature variation, it is also higher for inland. Okay, as I mentioned in the previous example, like in Punjab, Chhattisgarh, we have a cooler winter than our Odisha and the coastal states like Odisha, West Bengal, right? And seasonal temperature variation also affects global wind circulation. Like if we go to the higher altitude, in the tropical area, the seasonal temperature variation is less. Seasonal temperature variation is less in tropical area. And if we go in higher altitude, the seasonal variation of temperature will be more. Okay, there will be more coolness or hotness in case of, and the seasonal temperature variation, that is the fluctuation is more in higher altitude. Okay, or higher latitude, sorry, higher latitude, the seasonal variation of temperature is more than the equatorial region, because in equatorial region throughout the year you can find the direct solar radiation, but in suppose the sun the earth is getting solar radiation in this region, then in the then that will move, if sun will move in this direction, then the earth will get direct radiation in southern latitude. Then what will happen, there will be coolness will be more in northern latitude. So there is temperature variation will be more in higher latitude than the equatorial region, right? So the seasonal variation is more in higher latitude, right? Then another important point is, what is the effect or influence of atmospheric temperature on crop growth. The effect of atmospheric temperature on crop growth, how it affects our crop growth. All the physiological and molecular activity inside any plant or any organism that is directly affected by temperature. Okay, all the respiration, photosynthesis, every biochemical reaction that affects due to temperature, right? So how it, with respect to the crop growth, we have one cardinal temperature range. That is, what do you mean by cardinal temperature? That is the minimum temperature, maximum temperature and optimum temperature for a crop. Minimum temperature, maximum temperature and optimum temperature for a crop. So this cardinal temperature, again, this differ from for cool season crop, cool season and warm season crop. Okay, for cool season crop, the minimum temperature is 0 to 15 degrees Celsius. The maximum temperature is 31 to 37 degrees Celsius. The optimum temperature is 25 to 30 degrees Celsius. And for warm season crop, this minimum temperature is 15 to 18 degrees Celsius. Then maximum temperature is 44 to 50 degrees Celsius and optimum temperature is 31 to 37 degrees Celsius. This is cardinal temperature. Cardinal temperature comprises of minimum temperature, maximum temperature and optimum temperature. Then as I said, all the enzymatic activity and biochemical reactions, they are directly influenced by temperature. They actually increase with respect to temperature, and that increase in biochemical reaction or enzyme activity with respect to increase in temperature, that is called temperature quotient. Temperature quotient, or that is represented as Q10 value. What is this Q10 value? The rate of reaction at T plus 10 degrees Celsius divided by rate of reaction at T degrees Celsius. So on increasing 10 degrees Celsius temperature, how it affects our enzymatic activity, how it affects the biochemical activity. Okay, that is called temperature quotient. Then have you ever heard about growing degree day? Growing degree day, or that is also called heat unit. Okay, growing degree day or heat unit. Any crop, a specific crop require a specific amount of heat unit for its for its growth and for its maturity. Okay, any crop that required a specific quantity of heat unit for its maturity. What is that heat unit? That is the temperature that exceeds the base temperature. Okay, that is the difference between mean temperature and base temperature. That is specially heat unit means the difference between mean temperature and the difference between base temperature. Okay, so the formula of growing degree day is the summation of T max plus T mean divided by 2, that is the mean temperature, minus T base temperature. Okay, the summation of this, that is called the growing degree day. What is base temperature? That is the minimum temperature below which there is no growth can be observed. Minimum temperature below which there is no growth you can observe, that is called base temperature, and it is for warm season crop like rice, sorghum, that is 10 degrees Celsius. For cool season crop, that is like barley, wheat, oat, that is around 4.5 degrees Celsius. Okay, are we clear? What is base temperature? That is the minimum temperature below which there will be no growth you can find. Then what is growing degree day, that or heat unit? That is the difference between mean temperature and base temperature, or this is the formula. Okay, there is a limitation of this law, that is growing degree day or heat unit. There is a limitation. What is the limitation? The limitation is here we can see this is the linear relationship between temperature and duration. Okay, there is linear relationship between temperature and duration, but this is not true for every crop, or this is not true actually. If we go on increasing the temperature, if there is a decrease in the duration of the crop, that is not true in all cases. So this is the limitation of growing degree day. What is the significance of growing degree day? That is to find out the optimum sowing time and harvesting time, we require growing degree day to calculate the growing degree day. Based on temperature, what would be the right time for sowing and what would be the right time for harvesting, right? Next thing, to avoid this limitation, we have another formula that is called photothermal unit, PTU, that is photothermal unit. That is the summation of growing degree day into the day length, or length of day or night. growing degree day into day length. Okay, so here we are including another factor, that is the day length. So we to avoid this limitation, right? So this is all about atmospheric temperature and its effect on crop growth. So what we studied here in this chapter, what we studied: what is temperature, okay, how we can measure it, what are the units of measurement, right? Next thing we studied about latent heat versus sensible heat. Okay, heat transfer we studied different process of heat transfer like conduction, convection and radiation. Then latent heat versus sensible heat. Okay, then we studied the different type of distribution. Okay, horizontal distribution of temperature, then vertical distribution of temperature. Then what is lapse rate? Okay, different types of lapse rate like normal or average lapse rate, then actual lapse rate, then our adiabatic lapse rate. Okay, then temperature inversion. Okay, then what is specific heat, how it affects differentiation in temperature. Then what are the factors affecting temperature inversion, then about respiratory quotient, cardinal temperature, respiratory quotient like Q10, then growing degree day, then photothermal unit. All these concepts we have discussed in this particular lecture. So if you have any doubt, you can ask me in the comments section so that I will clarify all those doubts. Okay, so these are important. From this, if you find long question like long question, what are the effects of temperature on crop growth? One long question might be there. Another is how horizontal temperature variation and vertical temperature variation happens. That is long question. If we go for short notes, then you can find heat transfer, one method, that is short notes. Then lapse rate, different types of lapse rate you can find. Then temperature inversion, what are the factors of temperature inversion. Then from GDD you can find also one short notes. Then for short question MCQ, what is the lapse rate or adiabatic lapse rate value. Then what is specific heat and the value of specific heat. This can be asked in short question. So this is all about temperature, atmospheric temperature. See you in the next class. Till then, have a good day.